is mesh analysis, and we're working with circuits with independent voltage sources. The problem is to determine I sub 0 in the circuit shown below. I sub 0 is the output current through the 6 kilo ohm resistor in the center leg of the circuit. We have two voltage sources in this problem. We have a 12 volt source on the left-hand side, a 3 volt source on the right-hand side. So we're going to use mesh analysis, also known as loop analysis, to solve this problem. So if we're going to use mesh analysis, we know that we're going to rely on Kirchhoff's voltage law to solve this problem. Kirchhoff's voltage law tells us that the sum of all the voltages around any closed loop is equal to 0. So if we sum up the voltages around the loops that we identify in the circuit, the sum of those voltages at any instant in time should be equal to 0. So we're going to first identify, as we do with any mesh analysis problem, we're going to identify our loop currents or mesh currents first. So in this problem, we have a mesh on the left-hand side, we have a mesh on the right-hand side, and if we wanted to, we could identify this mesh on the exterior, the outer loop of the circuit as well. But we need, for this problem, two independent meshes. So we're going to start with identifying mesh 1 on the left-hand side of the circuit, and we're going to identify mesh 2 on the right-hand side of the circuit. So we have a mesh current 1 and a mesh current 2. And so we're going to use Kirchhoff's voltage law, and we're going to sum up the voltages around both of those loops. The first one that we're going to work on is loop 1. So if we start in the lower left-hand corner of loop 1 and we start traversing around it using the passive sign convention, we know our polarity drop is plus to minus across the 6 kilo ohm in the top of the circuit, and also plus to minus across the 6 kilo ohm resistor in the center of the circuit. So again, we're going to add up the voltage drops as we go around loop 1. And so if we start in the lower left-hand corner, start up the left-hand side, we encounter the negative polarity of the 12 volt source first. So it's minus 12 volts for our first voltage drop. We come up and we meet the 6 kilo ohm resistor at the top, and we hit the positive polarity first, so it's going to be plus, and then the voltage drop there is going to be 6 kilo ohms times I1, because that's the current flowing through the 6 kilo ohm resistor at the top of the circuit. We then pass that resistor and come down through the resistor in the center part of the circuit. If we come down through the resistor in the center part of the circuit, we see that we have, again, a plus to minus voltage drop, but the current flowing through that 6 kilo ohm resistor is going to be I1 minus I2, because I2 is flowing the opposite direction. It's flowing through the 6 kilo ohm resistor, but it's a contribution from loop 2. So it's going to be plus 6K I1 minus I2. And if we go beyond that, we get back to the beginning of the circuit, and that's the end of our loop. And so that's equal to 0. So our first equation has two unknowns, loop current 1 and loop current 2. Let's look at loop 2. Ultimately, if we can find another independent equation which has I1 and I2 in it, then we can solve these equations simultaneously. We have two equations and two unknowns. So let's do that. Let's start with the lower left-hand corner of loop 2, come up through the 6K resistor, the 3K, and then the voltage source on the right-hand side of the circuit, and back to the beginning. So first thing we have is the voltage drop across the 6K in the center of the circuit. So starting there, we have a negative polarity. It's negative, and it was 6K I1 minus I2. Then we continue up. At the top of the circuit, we have the 3 kilo ohm resistor, which just has current I2 flowing through it. We know the polarity of the voltage drop is plus to minus using the passive sign convention, so it's 3 kilo ohms times I2. And then we continue, we hit the positive polarity of the 3 volt source, so it's plus 3 volts. Continuing on back to where we started, and that's equal to 0. So if we look at equation 2, it has I1 and I2 in it. And so we have this set of equations where we have two equations and two unknowns. And we can solve for I1 and I2. So when we're doing mesh analysis, that's kind of the first thing we do is we solve for these mesh currents. So if we solve for I1 and I2 in this problem, we get an I1 equal to 1.25 milliamps. And we have an I2 which is equal to 0.5 milliamps. Now, how do those relate to I0? Because we're really looking for I0. And so I0 is the current, again, through the 6 kilo ohm resistor in the center going downward through that leg of the circuit, through that branch of the circuit. We know that I0 is going to be equal to I1, which is flowing the same direction as I0, minus I2, which is flowing the opposite direction up through the center leg of the circuit. So if that's the case, we can subtract I2 from I1, and we get 0.75 milliamps for I0. So we, again, summed up the voltages around the loops. So a point of interest that makes this a little easier in some cases to write your equations is looking at the 6 kilo ohm resistor in the center part of the circuit. We identified that voltage drop as plus to minus 6K I1 minus I2. Okay, so it's 6K I1 minus I2 for that voltage drop as we're going around the circuit in the left-hand loop. As we go around the right-hand loop, we had to add up the negative of that as part of our loop. It's the very first term in our second equation. And it was a minus 6K I1 minus I2. So I'm going to put a negative sign out here in front to reflect that. So that's our voltage drop as we go around the second loop associated with a 6 kilo ohm resistor. It's important to note that this minus 6K I1 minus I2 is equal to, it's the same thing as saying 6K I2 minus I1. Okay? So as we go around this loop, let's look at it again. If we start here at the lower left-hand corner and we start up this loop, and this is our first voltage drop we encounter in the second loop, this loop around the right-hand side of the circuit, it's equal to 6K I2 minus I1. 6K I2 minus I1. It's the same expression as the minus 6K I1 minus I2.